covers section 2.2 in the text. Let's first begin by looking at figure 4. Figure 4 shows what we saw in the last section. It shows the runner running along, and we've replaced the runner with dots, making a particle model. Notice this green arrow. This green arrow is an arrow that points from the origin to the position. This arrow is what we call a position vector. This arrow represents the runner's position, the distance and direction from the origin to the object. In general, distance is the entire length of an object's path, even if it moves in many directions. But for much of this chapter, in the beginning, we'll be moving not only in one dimension, but we're moving in one direction. So in that case, when you're moving in one direction, the arrow represents the distance. The length of the arrow represents the distance. So there's two kinds of quantities in physics. There's what's called a vector and a scalar. A vector, for example, what you just saw with the position, is a quantity that has both magnitude and direction. In other words, it has a certain length and it points in a certain direction. For example, this is a vector here, and it has a certain length, and in this case, it points to the left. So this would indicate that the person was moving towards the left. There are many things in physics you'll see coming that are examples of vectors. Position is the first one you've come across. In a minute, we'll see something called displacement. That's a vector. But there are some things that are just numbers. Just numbers are things called scalars. Examples of scalars would be, say, time and mass. Here we have a simple definition of a time interval. That's just the period of time on which something happens. It's simple enough. You've seen the delta sign before. It just means the difference between two times. Here we see, again, our favorite picture of a runner and position vectors this time. So they show, for example, if the initial position at a point after the race is 5 meters in, then we could draw an arrow from the origin to that position and call it position, the initial position. Suppose later the person is over here at 25 meters, so then we could draw another arrow, another position vector from the origin to that final position and label it x final. Displacement is defined as a change in position. So they went from 5 to 25. The change in their position, or delta x, is 20, or the length of the arrow is from 5 to 25. So you see, it has, like the time, it's simply the difference. But what you need to remember, and that's why I showed you the last figure, is unlike time, which is a scalar, position is a vector. So this is a difference between two vectors. And again, you want to think about it here as well. The big vector minus the little vector, the answer, the change, is from here to there. We'll work more on vectors in a minute. Speaking of vectors, we're going to need to know how to operate mathematically on vectors. And we're going to begin by adding and subtracting vectors in just one dimension. In other words, just like we've been moving along a flat, straight path. Key word you need to know is when we do the math and we come up with the answer for the addition or subtraction of two vectors, the answer is called the resultant. So I just want you to recognize that when you hear the word resultant, what they're asking for is the answer to a vector addition or subtraction problem. So let's look. How do you add up vectors? Well, suppose you have one vector drawn from the origin to some position, and you want to add a second vector. What we've done here is we've lined up the two vectors head to tail. The arrow head is lined up to the tail. So think of it sequentially. You start at the origin, you move to this point. Once you're at that point, you move to the next point. So you line them up head to tail. Now to find the resultant or the answer when you add those two vectors, you simply draw a new arrow or a new vector from the tail of the first all the way out to the head of the last. Does that make sense? Simple steps. Line them up head to tail. Draw the resultant from the tail of the first to the head of the last. How do you subtract vectors? Well, the secret to that is to remember that subtraction is just the addition of a negative vector. Well, what's a negative vector? A negative vector is a vector that is the same length, it just points in the opposite direction. So, for example, going back here to B, if this is B, negative B would simply start here and go that way. It would have the same length, 2 kilometers, but it would point to the west. So, here's how you subtract two vectors. Again, you're given vector A. Now, B this time, negative B points in the opposite direction, but you still line it up at the head of the first vector, you put the tail of the second vector. This time it simply goes in the opposite direction. And then the resultant, same as before, begins at the tail of the first vector and goes to the head of the last vector. All right, let's try the self-check, see if it's making sense. In a coordinate system, the blank is the point at which both variables have value 0. So, kind of a funny question, but the origin, that's where things begin. Okay, in this motion diagram, the length of an arrow indicates how far the object it represents is from the origin, or the distance from the origin. Remember, the length is connected to the distance. The entire arrow would be called the position, but they only asked about the length. In this image, 7 centimeters represents the what? Well, it looks like they took 5 and lined it up with 2 and then drew the resultant from the tail of the first to the head of the last. So that's the resultant. Final position minus initial position. That's a definition of delta x, or displacement. I hope this screencast helps. Bring your questions to class.